On this next example, some people think that you square the 3 and get 9, and the square and the square root cancel out, and so that this would be 6. But that is not true. This is not the correct way to multiply this. What the squared means is I am multiplying this by itself. I am multiplying 3 times negative 6, negative square root of 6, and 3 times negative square root of 6. I need a box problem. 3 times 3 is 9. When you multiply that, 3 times negative times negative makes a positive, and that would be the square root of 36. So I have 9, and I have 3 of these and 3 more of these. And the square root of 36 would be the whole number 6. Square root of 36 is 6. 9 plus 6 is 15. So when you have a binomial squared, you can multiply it together with a box problem. Two square root of 5 squared. That means the 2 is squared because there's a parenthesis around the whole thing. The 2 is squared, and the square root of 5 is squared. 2 squared is 4. The square and the square root cancel each other out, and so the answer is 20. And I don't know why I put a 4 here. This would be example number 7. And this would be example number 8. I'm multiplying a binomial times a binomial. To multiply a binomial times a binomial, I'm going to use a box problem. And this is going to be 3 and negative square roots of 3. 3 times 2 is 6. That's 3 times the square root of 8. Negative from that negative right there. And 8 times 3 would be the square root of 24. So I'm going to have 6 plus 3 square roots of 8 minus 2 square roots of 3 minus the square root of 24. I have some numbers here that can be simplified, and so I need to simplify the 8. 2 will go into 8 4 times, 2 will go into 4, and 2 will go into 2. And so I have a pair of 2's. I'm doing this 8 right here. This 8 right here already had a 3 out in front. And then I have a pair of 2's from this pair right here. And then I have this 2 right here left over. The square root of 3 can't be simplified any. 24 divides by 2. 12 divides by 2. 6 divides by 2. 2 will go into 6 3 times. And so here I have a pair of 2's. 3 times 2 here is these 2 right here multiply together to get 6. Let's go ahead and do that. Minus 2 square roots of 3. And I am simplifying the 24 here. So we're going to have a pair of 2's, and then left over in here, 2 times 3, we would have a 2 times 3. So 6 plus 6 square roots of 2 minus 2 square roots of 3 minus 2 square roots of 6. And none of that can be added together, because in order to add, you have to have the same number under the radical sign. Let's talk a little bit about terminology. This sign is called a radical sign. The number under the radical sign is called a radicand. If you have a number up in here, this number is called the index number. And this number tells me whether I want groups of 3 or 4. And if there is no index number written, the index number is 2. It's just a regular square root. And we are going to look at adding and subtracting radicals. To add or subtract radicals, they must be like terms. First of all, they must have the same index. You can't add a square root to a cubed root. The index must be the same, and also the radicand must be the same. These are both square roots. The index for both of these would be 2. If the index is not written, the index is 2. But you can't add these together. These do not add together to get the square root of 5. They do not add together to get the square root of 6. You cannot add them together because they do not have the same radicand. They don't have the same number under the radical. Okay, this has the same number under the radical, but it doesn't have the same index. These cannot be added together. That messy number there's a 4. These have the same index. They're all square roots. The index is 2. They have the same number under the radical, and so they would add very similarly to something like this. If you have x's instead of radicals, you would add 3 plus 4 plus 1, and that would give you 8x. We're going to do a similar thing with this problem. 3 plus 4 plus 1 more would give you 8 square roots of 2. But before you when I look at that, I do not see the same number under the radicand, so it doesn't look like those could be added together. But before I make that decision, I need to simplify the 8. So there's a pair of 2's here, so I have a pair of 2's on the outside and a 2 on the inside, plus this 2 right here, and then I need to simplify 18. And so here I have a pair of 3's with a 2 left over. So this is 2 square roots of 2 plus 6 square roots of 2. After I simplify them, I do see that they have the same number under the square root sign. So 6 square roots of 2 plus 6 square roots of 2 would add together for 8 square roots of 2. So before I add or subtract, I need to simplify so I can tell if the radicand is the same. When you subtract, you need to distribute a -1. So this would be -2 minus a minus so it doesn't look like anything adds together, because in order to add them together, you have to have the same number under the radical sign. But before we decide that for sure, we need to simplify the 27. 27 doesn't divide by 2, so I divide it by 3. I continue dividing by 3 until I get to the 1 on top. The 27 is equal to a pair of 3's with a 3 left over. And so that's the 27, 3 plus. So you combine like terms. Those are like terms. 3 plus a -2 gives you a 1. 3 plus 1 more gives you 4 square roots of 3. Now, a lot of people get this problem. Oh, I need a plus sign in here. Get this problem and this problem mixed up. Before I started distributing, this problem has a negative sign here. This problem doesn't have any sign in between the parentheses. If there is an adding or subtracting sign in between the parentheses, you simplify and combine like terms. If you don't have an adding or subtracting sign in between the parentheses, then this means it's a binomial times a binomial. So 3 times 2 is 6, 2 square roots of 27, 3 square roots of 3, and the square root of 81. When I multiply 3 times 27 together, that's equal to 81. There was a negative sign in here somewhere. This was a negative sign, so that would be a negative sign. So that would be a negative on the outside of the square root. So we have 6 plus 2 square roots of 27 minus 3 square roots of 3 minus the square root of 81. Now we simplify the 27 right up here, so we know that the 27 is 3 square roots of 3. That's equal to the 27 minus 3 square roots of 3 minus 81 is a perfect square number. The square root of 81 is 9. So we have 6 plus 6 square roots of 3 minus 3 square roots of 3 minus 9. Combine like terms. That would give me a negative 3. This, 6 subtract 3, this is multiplying a binomial times a binomial. The previous example was a binomial subtracting another binomial. I want to do one more simplifying example. In order to simplify, you do a birthday cake. In order to do a birthday cake, if possible, you start by dividing by 2. 2 will go into 12, 2 will go into 6, and so that will be 3. Now, this is not a square root. This is an index of 3. That makes it a cubed root. That means instead of looking for groups of 2, I am looking for groups of 3. I have a group of 3. And I have this 3 left over. 1, 2, 3, 4. X to the 4th power. I have a group of 3, and I have a X left over. So if you understand how to do the birthday cake, it's very easy to transition to an index of 3 instead of a square root.